Alright, here we go with the next part of these solutions. Solve the inequality and graph its solution. Okay, well let's just deal with this. There we go. 16 minus 4n is less than negative 2n. I'm going to expand that bracket. Negative 4 by 2n is negative 8n, and negative 4 by 2 is negative 8. Simplify the right hand side before we do anything else. Negative 10n minus 8. I want to get my like terms all together, so I'm going to add 10n to each side. That way I'll end up with a nice positive coefficient of n, which is nice. If my n's are going to be on the left, I want to get rid of this 16. So I'm going to subtract 16 from each side. What do we end up with? Negative 4n plus 10n is 6n. Of course, we know the 16s are going to cancel. 16 is less than 16 and 8, 24. 16 is less than negative 24, dividing by 6. N is less than negative 4. We make sure we've labelled our axis as n. Less than means it's an open circle, and less than is off to the left. You don't need to draw it all the way. The arrow on the end implies that it's going that way. Although, you would get out your ruler and make sure you did that nicely in an exam, but not too bad. Hopefully that was a good one for you. This one here, we didn't even need to do any thinking. M is less than negative 3. Label my axis so we know it's M. There's negative 3, and I want everything less than it. N is greater than 2.7 is the next one we're after. 1, 2. If you've given something like that, make sure you label the point. 2.7. It's an open circle again, and greater than is to the right. So there we would have N, labeling the axis. N is greater than 2.7. Oh my goodness, a few little order of operations things. 6 plus 2 minus 2. Well, that was nice, wasn't it? That's 6. 6 times 4 minus 1. We do our multiplication first. That's 24 minus 1, which is, of course, 23. I would expect you to be able to just write the answer for that one. Here we have 1 plus 8 squared is 64. Take away a negative. When you subtract something negative from your life is better, so that's a positive. Taking away a negative. Somehow I have zoomed in radically. That was a neat effort. There we go. Subtract. Negative 5 means to add 5 there. So I'm going to have, I said 64 and only wrote a 6. That's interesting. 65 plus 5, 70. Check that again. 1 plus 64 is 65 minus negative 5, add 5, 70. Very good. Here we have something we can simplify. Let's just do it by simplifying the denominator first. 2 plus 4 minus 4. Oh, the plus 4 and minus 4, that's going to be 0. So it's just going to be 2. Negative 2 over 2, which is, of course, negative 1. Evaluate by substituting in numbers. You should be pretty good at this by now. Y is 8. X is negative 5. Outside of 4, and Z was 2. Divided by 6. Well, if you're sharp and you're having a keen look, you'll see that 4 plus 2 is 6. And this negative 5 is going to be multiplied by 6 and then divided by 6. That common factor can cancel, can't it? So, 8 by negative 5, negative 40. Over here, question 61. Somehow my pen got thinner. I hope you can still see it. Replacing x with 5. Good habit to replace it with the number in brackets. It's not going to be so important in that case, but good habits are good habits for a reason. Let's make sure we use them. Z is negative 1 squared minus x is 5 again. And so we're going to have 5 minus 5 and negative 5. They're going to cancel. Negative 1 when I square it is going to be positive 1. So this is 5 minus 1. My total is 4. Sketch the graph of each line. Back to sketching graphs. X plus y equals 0. Well, my x-intercept and my y-intercept are 0. That didn't help me much, did it? I hope you can see that having seen them in the last few. Remember, if I let x equal 0, y is 0. If I let y equal 0, x is 0. That's great, but how do I find another point? Well, let's just rearrange it into y equals mx plus c form by subtracting x. Oh, y equals negative x. So my gradient's going to be negative 1. I'm going to go down 1 and across 1. And I seem to be doing all sorts of things without meaning to. Doesn't like it when I try to draw circles. Maybe I should do little crosses like that. All of those points follow the gradient of -1, so I should be able to get my graph going straight through all those points. And there you have it. You'd label your graph x plus y equals 0. Not so bad. Over here on the right, again, it's in nice y equals mx plus c form. Let's see if I can choose a different colour. Why not? My y-intercept is -3. My gradient -3/4. So I would go down 3 and across 4 to get to the next point. That should be enough to draw the line. I think if I start it there, it should be roughly right. Look at that. Getting better at something. Hopefully you're getting better at your maths and I'm getting better at working with this tablet. It's a lot easier at school where I can see what I'm writing on. Y equals -3/4, x take 3. And we're done. Oh, one more. X equals y. Well, this has just got a y-intercept of 0 and a gradient of 1. So that's pretty easy as well, isn't it? Can sketch that one in no time at all. Well, yes. Oh, that'll do. X equals y. Hopefully that helped for you. You might have been able to draw it a little bit neater than I did. Find the slope or the gradient of each line. This is in y equals mx plus c form. So my slope, my gradient is -1/5. Next one here, the gradient is -3/2. Nice and easy. If I want to actually find the gradient through 2 points, you've got lots of ways of remembering this. Rise over run, which is more useful if you're given a graph and you're counting the points. What's the other way we can do it? The change in y coordinate divided by the change in x coordinate, or the vertical change divided by the horizontal change. What is that when you're actually using a formula? It's the difference in the y coordinates. y2 take y1. That's how I find how much it changed. Divided by x2 take x1. All right, well, make sure you label your points, because otherwise people have the strange tendency to go like 3 minus 15 and -19 minus 11. So if you label your points x1, y1, x2, y2, it should prevent any problems. So in this case, the gradient is going to be -19. That's my y2 minus y1. -19 minus 3 divided by -11 minus 15. And that gives me a gradient of -22 over -26. Well, they're both even and they're both negative. Let's simplify that a little bit. M equals, dividing by -2, I'm going to have 11 over 13. And we are done with that one. Find the slope of this line. They should really give you a scale, but it's actually okay. We can, assuming that it's the same vertically and horizontally. 1, 2, 3, 4, 5, 6, 7. We have a rise of 7 and a horizontal run of 3. So my gradient is 7 over 3. Parallel lines have equal gradients. So find the slope of a line parallel. Ooh, x equals 1. What's the gradient of that? I know y equals mx plus c, but there's no y in this one. That's right, you're remembering, aren't you? X equals 1 is a special line. It is a vertical line. This is my x-axis. Here's a point where x equals 1. Where are all the other points where x equals 1? All in that vertical line. Now, what's special about the gradient of a vertical line? Well, remembering back to our gradient equals our rise over our run, if the run is 0, that would give rise over 0. We know that division by 0 is undefined, so therefore the gradient of a vertical line is undefined. And since this line would be parallel, it would have a gradient that would be undefined too. Perpendicular lines, if you have two gradients m1 and m2 and they are perpendicular, you could multiply the gradients to equal -1, or to find the second gradient, it's just -1 divided by whatever the first gradient is. So in this case, the gradient of the given line is -5. So I'm going to say the gradient of a perpendicular is going to be -1 divided by that gradient, which was -5, which is, of course, 1/5. So the gradient of a perpendicular line to the given line would be 1/5. Write the slope-intercept form of the equation of this line. We'll have a y-intercept c of -5. What's my gradient? Well, I've gone up 1, 2, and across 1. Oh, my gradient is a rise of 2 divided by a run of 1. Oh, that's just 2. So y is going to equal 2x minus 5. That would be the equation. If you wanted to check a point, let's sub in x equals 4. 2 times 4 is 8, minus 5 is 3. When x equals 4, y equals 3. We know we got it right, which is always nice. Write the slope-intercept form of the equation. Given this information, kindergarten work, isn't it? Y equals -6x plus 3. Slope-intercept, gradient-intercept. Same thing. Let's have a look at the next one. Oh, we've got a slope of 3/5, so I'm going to have y equals 3/5 x plus c. They haven't given me the y-intercept this time, so what am I going to say? I'm going to substitute in the given point, 5, 0. Because if that point is on the line, then it's going to make the equation true, which will let me evaluate c. So I'm going to let y equal 0. 3/5, replacing x with 5. Plus c, I've got 0 equals, 3/5 by 5 is just 3. Remember, that's 5/1 and the 5's cancel, just in case you'd forgotten that. And finally, 3 plus c, well, I can subtract 3 from each side. I've now got my value of c. I knew my value of m, so the equation is y equals 3/5 of x minus 3. Finally, when we were given 2 points, well, we know we need the gradient and the intercept, so let's find the gradient. We should recall that it's the difference in the y-coordinates, y2 minus y1, so -4 minus 3, divided by the difference in the x-coordinates, -4 minus -1. So I've got a gradient equal to -7, -4 plus 1 is -3. My gradient is 7/3. So therefore my equation is going to look like, it's going to be in the form y equals 7/3x plus c. Is there a good one to substitute in? 4 and 1, neither of them are going to be nice. Let's just use -1 and 3. So let sub in, substitute. I'll try and write a little bit more neatly than that. You can see it's getting late. Substitute -1, 3 for x and y. So I'm going to have 3 equals 7/3 times -1 plus c. So 3 is going to equal -7/3 plus c. I've got to add 7/3. 3 was 9/3. That's going to be 16/3 equals c. So from all of that, I now have the equation y is going to equal 7/3 x plus 16/3. Nearly there. I think we can do a couple more slope-intercept questions now while we're on a roll with them. Write the slope-intercept form. If it's parallel to this, so I know my gradient is going to be 2/5, so it's going to be y equals 2/5 x plus c. I'm going to sub in the given point. -5, -4. So -4 equals 2/5 of -5 plus c. Leave the left-hand side alone for a minute. Remember, the 5's are going to cancel 2 by -1 will be -2 plus c. Adding 2 to each side, I get -2 equals c. So my equation is y equals 2/5 of x minus 2. Like the last one here. going through the point 2, 0 and perpendicular to the line. So the gradient of a perpendicular line, so last time I wrote perp, this time you can use the symbol for perpendicular if you like, is -1 divided by the gradient of this line, which is also -1. So the gradient of the perpendicular line is 1. Okay, I know that y equals 1x plus c. Sub in the value that we have been given, the point, when x equals 2, y equals 0. So I'm going to have 0 equals 2 plus c. -2 is equal to c. I've got my gradient. I've got my y-intercept. So y equals x minus 2 is what we're after there. Alright, catch you in the next video. Hopefully you're going well with these. Cheers, guys.